Hello everybody. When you start learning calculus the first time, there are so many confusion. The reason is the textbook doesn't explain everything. The teachers skip around and the important things are missing, and that's why you try to figure it out. There are a lot of question rises. Okay, so this is a video to fill that the void you have during the learning calculus, to make it calculus easy. If somebody explains this, there's no hassle, there's no difficult part of in a calculus. Anybody can understand. Okay, so the first word come up is a slope. And slope, how do you define the slope? When you have a function like fx, the curved function like that, the average slope is probably you take appropriate point here and take this, the x increase and the y increase, right? So you did calculus delta y delta x and make this point very close so that it's going to be the slope of this function. Well, here you do this without defining what the slope of the curve. What is the slope of the curve? Okay, average slope and straight line slope, we learned that in the geometry and algebra, but we didn't define what the slope of the curve, this point. Okay, so how we define this? Without defining slope, you do this in a calculus, then you get confused. What are we trying to calculate? Slope? What is a slope? Slope. Define it first, right? So this is how we define it. Suppose you have line intersecting two points of the curve. Move this slowly out of the curve. Then this 2 points merge into 1 point. So there is only one contact point. If you move further, there's no more contact. So 0 contact and 2 contact, there must be a point that you have only one single contact. Okay, and this line gives a slope. So we define the slope of this point. Any other curve, same thing. If curved like that, what is the slope here? You know, you're climbing hill. What is the slope at this point? Okay, this is a point, the line contact single point. If you cheat, this slope looks a little bit flatter, then it's intersecting 2 points. So that's not the slope of this point. If you say, wow, this hill looks very slopey, actually I think this is the way. But if you tilt this line, it's going to contact 2 points. So that's not really slope of this point. This point of slope is obtained only when you find the line that just contacts single point. Is that possible? Well, not always. We explain this later. Okay? But let's calculate this m. How do we get this slope m, right? And we use this delta y delta x stuff in the limit and stuff. No, we don't need that. We use algebra to calculate. How can you do derivative using algebra? We can, no problem. Suppose fx is quadratic function a x squared plus b x plus c, right? then slope function at x1. Okay, say this is x, this point is x. Okay, so it's going to be mx plus L, right? And if they are going to intersect, that means that equal. So y, the height is equal. We find this point. When we get this point, okay, we change this. Equation and solve this quadratic equation. The quadratic equation, you know the single root. Single root means minus b plus minus square root blah 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 2a, right? This part is going to be 0. So we worry about this only, this part. Here it's going to be the root x1 equals 2a, and instead of b minus m and negative, right? So m, here you go, to get x1 plus b. Minus b, this plus b, is that correct? Because this part, square root part, is 0 for single roots. So let's see, m is correct, b, okay, this is correct, right? So what is this m? The m, okay, what is m? Actually, we assume m is the slope of this function. So we got a slope here. So if you learn derivative, right? X squared's derivative is 2x, which is this part, 2 and x, right? And x derivative is 1, so this part, x disappear. You take a derivative of this, what's happened? 2ax plus b. So we got derivative function. So m is a function of x1, right? 2ax1 plus b. So this is a slope. So derivative function is a slope actually of this curve here at given x1, or it can be x. You can use either way. Okay, so if you make a new coordinate here, okay, then m equals 2ax plus b, and this m, we write it derivative of original function f prime x, right? Or you can write d dx fx. This is just convention. Instead of prime, you can use this way, equals mx. So what is the derivative now? It's a slope. Get it? And you can expand this into x cube, fourths, fifths, whatever, any function, even various other elementary function like exponential function, sine, cosine, you can expand it, right? So solving the equation like this is not always possible. So what do? We use this mathematics method to calculate m. That's why you use delta y over delta x and the limit stuff. Okay? So even y is more complicated function, we can calculate using this, the m. You can't solve it using algebra. Now you are a little bit higher level in the game. You got a higher level here called calculus. Calculus give you tools, the magic point to calculate the more complex function, the slope. But idea is the same. Derivative is a slope. Okay? So what happens if the curve is like this? Sorry. Like this. Forget about this. Okay, this curve give you the slope. This curve give you the slope. So you have a kink point has two m value, two derivatives. Okay, and this is called not smooth function. But you know, not smooth, how do you define smoothness? You know, you touch this by finger and say, oops, there's a kink here. Okay, then that's not smooth, but that's a physical definition of smooth. How do you define smooth function in the math? Well, easy. You have single value function. Derivative function. Single value derivative function. You can't have a two value. If you have two value, original function is not smooth. Okay? And some math book said, in order to have a derivative, function has to be smooth. Okay, fine. To have derivative function, you have to be smooth. But this one, you didn't define what the smooth is. Actually, in fact, this is the opposite. Okay? If you have derivative function is smooth. That's what it is. And some calculus books are confused about this. And you get confused because they don't understand calculus. Serious. Some textbook writers, they don't really understand the math. They just copy the previous textbook and write up and add something which is wrong. Okay? Now, when function is, here you go, discontinuous. Okay? We show value existing here with white dot, or if value existing here is black dot, right? The either way, tangent m1 and m2. At this point, we cannot define m1 or m2 value. Okay, if it's black dot, we can say, yeah, this slope is like that, but we don't talk about this side slope. So one-sided slope, right? If white dot, you can do same thing actually. We can talk about slope on this side, but not this side. So this will raise a flag in this derivative. Derivative unknown at this x1. Okay, so there are such a cases more, like here, this function, right? It's disconnected here. So this point x is 0, derivatives is unknown, right? And you know what you call this kind of point, right? Okay, so that's all you have to know about derivatives actually. Okay, now a little bit boring part. Derivative, you can do derivative this way. Okay, fine, because this is a quadratic function. The quadratic function, you add them and take a derivative, same as take a derivative each and add them. And if you have this derivative, you can do this. Constant can move out, right? And combine them together. B gx will be a f derivative plus b g derivative, right? And this is called linearity. Linearity of derivative operation. Okay. Now, how about multiply? This is outside of linearity, okay? It's going to be fx gx plus fx gx. So derivative of each function multiplied by original function, and you add them together. And last part, divide. Ooh, this is the part you may not like it. What is the derivative of this? Okay, f x f square g x fx minus g x fx derivative. Is this correct, right? Let me know. Check it out, okay? See, I did calculus long time ago, and I still remember the formula of divide, but I may be wrong. Go ahead, find it in the textbook. Find out. So, what's good about this is like sine x over cosine x derivative. This is like a tangent x derivative, right? And this can be calculated using this. So it's cos square minus over sine is going to be cos x, and cos is going to be sine cos square plus sine square, and this is going to be 1. Okay, so 1 over cos square x. Okay, seems like it's correct. Okay, so that's all about derivative. Well, next time we talk about, then what about this? The stuff I hate. Limit delta x. What kind of a trick is this? Well, as I said, this is a tool given to only higher level. After you clear all the algebra field, you go to the next level, just like a game. Okay, you go to next level, you become higher power character, then you get this sword in your hands and slash things around. Okay, that's what it is. So in order to use this tool, you have to know how to use it. Okay, we talk about this one in the next video. If you like it, please hit subscribe and give me a good evaluation so that I can continue this easy calculus course. Okay, bye.